Okay, let's get started. Everybody, can you see my screen?
Yes, we can.
Okay, great. Um, as you know, in last class, we are solving problems, and I think we are done problem number 1. So, can you now start problem number 2, 3? So, problem 1 was about long shunt compound generator, and problem 2 is about short shunt compound generator. So, the armature current and load current of a short shunt compound generator are 20 ampere and 4 ampere respectively. If the series field resistance, armature resistance, and shunt field resistances are 0.5 ohm, 0.9 ohm, and 5 ohm respectively, then calculate the generator terminal voltage. If the flux for is zero point 0.2, total number of armature conductors is 20, safety speed is 1800, and the number of parallel paths is the same as the pole number. And then I have written down the answer for you, so you can check that you're right. Uh, so the first task is that for number 2, first draw a short shunt compound generator picture. Draw a short shunt compound generator picture. So to do that, in case you might have forgot, so everybody see this slide. So these middle figures, figure number D or figure number E, these are the short shunt. Therefore, everybody please draw these figures, either of the pictures, D or E. See, this is the short shunt. And you see that, of course, the bottom one was the long shunt that you did in the previous problem number 1. So now everybody please draw this on figure D or figure E. I mean, it's the same thing. There is series field, and then this is the shunt field. The one thing is not shown here, that you need to draw the armature resistance between point A1 and then this brass. So you need to draw a resistance. Everybody, are you drawing this picture? So in your paper, you please draw this figure number D or figure number E. This is the example of short shunt compound generator, short shunt. Because the shunt field is connected at point A on, accordingly it is called short shunt. Then the bottommost figure, that was the long shunt, because shunt field is connected all the way down to the load point. So you need to draw figure D only. So everybody please draw.
You said with the resistor right above or right underneath A1 as well?
Yeah. So therefore, just beneath the between A1 and then that, what is called brass, black colored brass. So here there should be the resistance RA. So this is the, the where it is written EA voltage, that is that circular body, that is the armature picture, armature symbol. And then those two, the bold black color, those are called the carbon brass. So therefore, draw the resistance between A1 and then upper brass, meaning that the here you draw the resistance, which will be the armature resistance. Is everybody hearing me?
Yeah, we can hear you.
Yeah. So what I said, that for figure D, one thing is missing here. I mean, this picture is taken from the book, figure number 8.12, but that armature resistance is missing in the diagram. So it should be between point A1 and then the top brass. This black color, this is called the carbon brass. So here you draw a resistance and then label it RA. That is RA, and then everybody say between S1 and S2, this is the series field coil. Therefore, inside that coil, there is resistance. So you can label this RSE, series field resistance. Yeah. So therefore, I am taking you to the problem soon. So in the problem, series field resistance is given. So although it shows the coil, but it has the resistance. That is the meaning. And then leftmost side, you see there is resistance on the coil. So because this is DC, coil will be automatically shorted, but that will be the shunt field resistance, the resistance. Has everybody drawn this diagram?
Yes, I have. Yes.
I've got it down.
Okay. Then now say, as I told you, and then everybody remember the series field is between S1 and S2. Therefore, resistance will be there. I told you to draw the armature resistance between A1 and carbon brass point, upper carbon brass point, and left side, that is the shunt field resistance. So now everybody go to the problem. Now read number 2 and then solve it. So therefore the armature current and load current of a short circuit compound generator, those are given. So 20 ampere is the armature current. So in your note where you draw the picture, you label the 20 ampere. That is going from source towards the point A1, and then 4 ampere, of course, on the load side. And then you see the series field resistance, armature resistance, shunt field resistances. Those values are given. They properly give those values. And then it says, calculate the generator terminal voltage. Then what should be the generator terminal voltage? Provided that the flux per pole is 0.2, total number of armature conductors is 20, safety speed is 1800 rpm, and the number of parallel paths is the same as the pole number. So therefore, what should be your first task? Your very first task will be, because the question is calculate the generator terminal voltage, for the diagram that you draw in your paper, first write down what should be the terminal voltage equation. That is the very first task. What is the terminal voltage equation by looking that diagram? So everybody please write down that one, and then you can solve. You can see what is given and what is not given. So therefore, I am taking you to the picture again. So everybody see. So where the terminal voltage will be at the rightmost 2 point. Here it is the terminal voltage Vt. You see. So therefore, if it is the terminal voltage Vt, then how to get that voltage? So first see the EA voltage, which is shown inside the armature symbol. Yeah, this is the main generated voltage. So therefore EA, then what? You all draw that armature resistance. So therefore we have to subtract that armature resistance drop. So therefore from EA you subtract armature resistance drop, which is IA multiplied by RA. And then again there is series field resistance, you see. So there will be another drop. So you have to subtract another drop. And in this case, you see the load current and the series field current is the same. Right? Everybody, could you follow me?
Yes.
Yeah. So because it is the same, actually load is at the end. So therefore load current and then series field current is the same. So therefore when you will be subtracting the series field drop, series field resistance drop, this means that load current multiplied by what is its resistance, which is given in the problem. Then you will be getting the terminal voltage Vt. So this means terminal voltage Vt equals to EA minus IARA. First subtract the armature, then minus that IL into RAC. IL means the load current multiplied by the series field resistance. That will be your Vt expression. So therefore everybody first write down that one. Is everybody following me?
Yep, got it down.
Yes. So then now you go back to the problem and then see what is given, what is not given. So that so the everybody see the thing is that uh, in the terminal voltage equation that you just wrote down, you see the EA is missing. This means you see the EA value is not given in the problem. Like EA minus I or a minus IL into RAC, then you'll be getting VT. That is fine. But EA is not given in the problem. Read the problem. EA is not given. That you have to find out from the information. So everybody read the full statement. Then you notice EA is not given directly. So that you have to calculate from the information. So therefore, what will be that EA expression? Can you remember? Like before we did, if you have your note, uh, EA equal to phi Gn over 60 multiplied by phi over A.
Do we know the number of the capacitors for
Sorry,
n of the equation?
capacitor
Uh, well, yes, for that equation, the phi z n over 60.
multiplied by phi over A.
Yes.
So yeah, so that is the equation that you have to use to calculate the EA, induced voltage. So then what's your question?
Oh no, I misspoke. I meant conductors, and now I just read it. The 20.
Oh yeah, okay, yeah. Everybody, did you hear us or that Moses was asking about that equation? EA phi Gn over 60 multiplied by phi over A. I mean, before we have used that equation. Just a moment. Yes, so everybody see, this is a different problem, but everybody see, this will be the equation. You can write down E equal to phi Gn over 60 multiplied by phi over A. Everybody, this will be your EA equation. I mean, this is a different problem. Just I have on my handwritten thing I am showing, but you note down this EA equation. That phi is that flux, capital G is the total number of conductors, N is the speed in RPM, phi is number of poles, and A is number of parallel paths. So therefore, write down this equation, or you already you might have in your note from the previous problem. Everybody, have you wrote down this equation? Okay, can you hear me?
Yeah, we can.
Yeah, so therefore, please write down this E equation. I mean, you already have, but I am showing again. E equal to phi Gn over 60 multiplied by phi over A. This will be your EA equation. So now I am going back to that problem. Oh, sorry. Okay, so you are doing number 2. So now everybody see. So once you write down that VT equation, terminal voltage, and then see in the equation EA is missing, that you calculate from the information. If the flux per pole is 0.2, total number of armature conductors is 20, safety speed is 1800, and the number of parallel paths is the same as the pole number. So then finally you see that you should be getting terminal voltage result is 100. And then let me know that you are getting that one. So everybody please try to understand and solve it. Then I think you will be done in two things. You have one homework, which is due on this Friday. And also next week, you will be facing your midterm exam too. The coming Tuesday, just 1 week away. And again, you will be facing similar problems. Therefore, everybody, please try your best to understand and use your pen and paper and calculator and solve this. So this is a very good practice up front. Are you all doing? So does anybody have any questions, any confusion?
Nope, I got the 100 volts.
Oh, okay, great.
120 should have been our EA for it.
EA value?
Yes.
Could be.
Yeah, it was 120, I believe.
Yeah, it could be. Yeah.
Yeah, that's what I
Then yes, I got 100. Yes, sir.
Okay.
I got 100 as well.
Alexandria, I could hardly hear you.
Okay, hold on, I'll try to.
I cannot hear you well, Alexandria. Jared, did you get the same number?
No, not yet.
Oh, okay. Okay, great. So, Muna, did you get the result or is still doing?
Can you hear me
Yeah, I got it.
Oh, you got? Yeah, okay. Okay.
better now?
Hello?
Can you hear me a little bit better now?
No, it's still the same, like very thin voice, very difficult to hear.
Okay.
I mean, I am hearing you, but very little.
It sounds like I'm far away.
So still, it looks like.
Yes.
So is everybody hearing Alexandria? Well,
Barely.
barely, yes, yeah.
I'm using one.
I just heard some noise.
Okay, I think.
Yeah, Alex, now it is better. Now fine.
Okay, thank you.
Yeah, now fine. Yeah. So keep this volume and adjust this one. So, Alex, did you get this result, 100 volt?
Yes, I did. Sorry, I put it in the chat. I ended up getting the 100 volts.
Okay, fine. Yeah.
Thank you.
So is everybody fine with 2 or is still doing? Should I move to 3 or is still you want to do? I mean, everybody take time. What I'm saying that everybody please make practice, hard practice here. Then you are asked similar question in the homework number 4 that is due on Friday, as well as you will be again seeing similar problem in the upcoming midterm exam 2, which will be held on coming Tuesday, October 22. So sorry, I think no, I think not coming Tuesday. I think coming Thursday will be October 22. So I'm sorry. Okay, so therefore, I think, where is it? Yeah, everybody see, this is number 2. So you see my handwritten. So this is number 2. You see, I have drawn that short shunt. Here is that array. And I wrote down those numbers and I have calculated here 120 volt. And then I am writing VT equation, EA minus IRA minus IAC RSA. I just gave them this current name ISA, series field current, or it is the same current as the IL load current. So you might use the symbol here IL, it does not matter. And then you should be getting 100 watt. So here is that calculation. Everybody see those who are still doing. But then I'm going to upload this slide together with this class note. So again, you can see later on the e-course here. So is everybody fine with this one? Number 2?
Yes, I think we're good.
Yes.
Okay, so therefore now I'm going to number 3. Everybody read number 3. Okay. See, calculate the field and armature resistance of a DC shunt motor when the input voltage and current are 230 volt and 15 ampere respectively. Also, the back voltage of the motor is 210 volt and 10 ampere current is flowing through the armature. So here you have to find out the field resistance and armature resistance of a DC shunt motor. And then I have written down the answer. Field resistance should be 46 ohm and armature resistance should be 2 ohm. So this is the simple DC shunt motor. It is not long shunt or short shunt, simple DC shunt motor. And input voltage and current values are given. Back voltage is given. Armature current is also given. Then find out the field resistance and armature resistance. So therefore, first of all, so what is the diagram of DC shunt motor? Therefore, everybody first draw a diagram for DC shunt motor. So therefore, if I go this one, you see the
B, right?
yeah, B, right. Everybody see the topmost B, middle picture. Middle picture. Everybody draw the middle picture, V. That is your DC shunt motor. I mean DC shunt generator or motor. And then label this one at the beginning, that is the VT. And because this is motor, so definitely current direction will be from that dotted terminal to AON. That will be from the source, it will go towards the AON. That will be current direction. And then again, the array is missing here, similar to the previous diagram. So everybody please put the array between AON and then upper that carbon bus. So put the array there between AON and then upper carbon bus, put the array value there. So this will be your DC shunt motor picture. And that will be your VT. And then of course the left side, that is F1, F2, that is the field coil. So accordingly, there is field resistance. So coil is fine because it will be short circuited. So resistance is the important. So resistance, and there will be array here between AON and carbon bus point. Everybody, have you drawn that figure B?
Yes, sir.
Yes, I got it.
Okay, just draw the middle figure. Yeah. So therefore your VT terminal voltage will be on the rightmost side between those two circled point. That is your VT, applied voltage, terminal voltage. And then the input current will be towards the direction of AON. And then armature current, of course, here. And EA is that. EA, if it is motor, then EA will be back EMF. Keep in mind, because we are treating this one as a motor. So definitely applied voltage VT will be greater than the back voltage. So EA is the back voltage or back EMF for motor. When it is generator, EA is the induced voltage or generated voltage, and VT is the terminal voltage. But for motor, EA is the back voltage, which will be developed later once the motor has started rotating. So okay, so with that picture, then now go back to the problem. So now everybody read that one. So for that DC shunt motor, you find out the field resistance and armature resistance. What is given? Input voltage is given. So that input voltage is your VT actually, and then current. Also the back voltage is given, EA value is given, and 10 ampere current is flowing through the armature. Then find out what is the field resistance and what is the armature resistance. And then see that you get the same result. Field resistance 46 ohm and armature resistance 2 ohm.
Got it.
So both are correct?
Yes, I got them both.
Yeah, okay, great. Is everybody working and getting the same result or anything?
Yes, I am.
So did you get both result, Moses?
Yes.
Not yet.
Okay.
Two.
Okay, okay. So like everybody see this figure. So this is the input voltage, terminal voltage VT, and then current is entering, which is input current. That current is divided into two parts. One portion is going through the armature, and then other portion is going to the shunt field. So you see, from terminal, the total current is coming, which is the input current, and that current is divided into two parts. One part is going to the armature, and then the remaining part is going to the field. So that's the concept of that shunt motor. Then I think you should be able to do. So is everybody fine? So did you all get or is still doing?
I'm good.
Oh, okay, great.
I got it.
Okay, good. I think, hold on. So everybody see? this one, number 3. Yeah. So you see that my diagram, this is my applied voltage VT, 230 volt, and that 15 ampere, that is the input current IN, and you see 10 ampere is going to the armature. So back voltage is 210, and then 15 minus 10, so 5 ampere is going to the field circuit, shunt field. So therefore, this is the voltage, applied voltage 230 appears between this point and this point, between A1 and A2, which is the same across that field. That's why RF is 230 over 5, so 46 ohm. And then RA, you will be getting from this equation, VT minus CB over IA. So therefore, VT given 230, EB is 210, then 10, so 2 ohm. So is everybody fine?
Yeah, looks good. Or matches
Oh.
what I did.
Sorry, what you said?
Matches what I did.
Okay, great. Yeah, okay. Okay, therefore, so everybody, those who are still keeping, then later you can see also. Okay, then now the on new topic, this one, although there is a problem here as well, but you see, I'll be discussing for a minute speed control of DC motor. You know that before we looked speed control of induction motor. So accordingly, the speed control of DC motor is very important. So what are the ways? There are 3 main ways. By field resistance control, you can control the speed. By controlling the armature resistance, as well as by controlling the armature voltage. So therefore, for a minute, I'll be discussing these 3 points. So everybody remember field resistance control, armature resistance control, and armature voltage control. So therefore, for a minute, I am taking you to that board. So everybody remember that our that equation that we are looking, for example, in case of the motor, that back voltage, I mean, that is still the same equation, that 5 Gn over 60 multiplied by phi over A. So therefore, here you can see the main thing is that actually 2 variable, that back voltage or that generated voltage is dependent on 2 factor. One is that flux, and then other one is that speed, rotating speed. The remaining things are constant. This is number of conductor, this is pole, this is parallel path, this is just the number. So those are constant. So you could write that equation E, that all the constant factor G over 60 multiplied by phi over A, you can say this is K. So therefore E K and then phi, then N. You can express in that way, equation. So from there, because N is the speed, so you can write down speed is that E over K phi. So that is your speed equation. Now, why I wrote down that equation? Because we are discussing about the speed control of DC motor. So you see, this is the flux, that phi, and that flux is that field flux. That is the field flux. And then that field flux is dependent on the current. So, you know, this is the field. For example, that IF current is flowing. The applied voltage to the field is VF. This is the field circuit. This is the field coil, LF, and this is the field resistance, RF. So therefore, as you can see, if you vary that resistance, this one, field resistance, then your current will vary. And if the current varies, then the flux will vary. So that's why you see that 3 points, that field resistance control. If you control the field resistance, that will control the field current, and consequently flux will be changed. If you decrease, then speed will increase. If you increase, then your speed will decrease. So that's why this is one factor, field resistance control. The number 2 point is, you all know this one. What is that I equation? Just you wrote a few minutes back. I is Vt minus that back voltage over Ra. So therefore, according to this equation, if you control this one, if you make that Ra variable, which is armature resistance, then again that is increasing or decreasing the current value. And that IA was that armature current. If armature current is different, then armature flux developed in the armature coil will also be changing. Consequently, the developed torque will be changing, and that will control the speed. So that's why you can control the speed by controlling the armature resistance. So this is the number 2 point. And then the third point is that armature voltage control. Definitely, as you can see, that even if you don't control this RA, let's say your RA is fixed, you are not controlling the RA, but you are changing the VT, main input voltage control, then definitely that will change your input current, which is going, or the armature current, which is going to the armature coil, that will again control the armature flux. Whatever the main field flux is, the interacted torque will be changed. Consequently, the speed will be controlled. That's why 3 methods. One is that armature resistance control, which will ultimately control that phi, this one. Let me give a variable symbol here. That flux control or field resistance control, armature resistance control, and then the input voltage control. So these 3 are the main factors. Everybody, could you follow me?
Yes, so far, yes.
Yeah, so that is the thing. I mean, again, I'm taking you to that slide. Those are the 3 points. So therefore, you might be asked these questions in any upcoming exam or other time final exam. What are the methods to control the speed in case of a DC motor? Then you will be telling that I can control the speed of DC motor by adjusting the field resistance, by adjusting the armature resistance, and also by controlling the input voltage or the armature voltage. So those 3 are the main factors. Okay, so therefore now everybody, once again, there is another problem. And then there will be some set of the quiz questions that again still you have to answer. I'm coming that point soon. Everybody read, there is another problem here. Please read and then solve this one. The shaft of a single phase 3 horsepower, 50 Newton meter, 60 Hertz induction motor is coupled to a DC generator that requires an excitation current of 5 ampere to produce 750 watt. If the flux per pole is proportional to the excitation current, then calculate the number of conductors in the armature windings of the DC generator. Assume the number of poles is twice the number of parallel paths in the generator. So the question is, you have to get the number of conductors. Like I got number of conductors is 3. That is the answer. So you have to get the G. So everybody see the thing is that because it is G, therefore again you have to write down that same equation that you used in previous problems, and I think the first problem today, that E equation, E equal to phi Gn over 60 multiplied by phi by A. That is the equation that you need to use. So everybody, that is the very first step. Please write down that equation, E equation. And then now see how to get the G, what is given and what is not given. So once you write down that equation, then you can see which parameters is given and which was not given and how to get that. Also in this problem, it says that induction, single phase induction motor is coupled to a DC generator. This means the DC generator shaft is being rotated or being driven by induction motor. That's why they are coupled together. So this means induction motor is the prime mover for the DC generator, because DC generator requires the speed rotation. That rotation is coming from that induction motor. That's why at the beginning it says the shaft of a single phase 3 horsepower 50 Newton meter 60 hertz induction motor is coupled. So induction motor is helping rotate the DC generator shaft. So therefore, at first you can draw a schematic. For example, induction motor, and draw its shaft, and that shaft is connected to the DC generator shaft. This means both the induction motor and DC generator, they are sharing the common shaft. Their speed is the same. Everybody, could you follow me? So you have to find out the number of conductors, which is that capital G, but then capital G is related to DC generator. So that's why at the beginning, everybody, please write down that E equation, induced voltage equation for DC generator, which is we just discussed and I showed on the board, and also you did on the first problem today. E equal to phi Gn over 60 multiplied by phi by I. And then E value is given, which is 750 volt. Now, everybody look, regarding the flux, it says flux per pole is proportional to the excitation current. What is the value of excitation current? It says 5 ampere. Therefore, your flux per pole will be 5. That is the meaning. If we assume that proportionality constant is 1. So see here, the flux value is not directly given. It says from the last portion of the third line, if the flux per pole is proportional to the excitation current. So and then in the previous line it says excitation current of 5 ampere. So this means you can say that flux is proportional to that 5. And then I assume that proportionality constant is 1. Accordingly, your flux phi value will be just 5 webers. Phi value will be 5 webers. And then you all calculate. And then as I said, how you will get the speed n in the equation? Because the DC generator shaft is connected to the induction motor shaft. It is the same shaft. So therefore, if you can find out what is the speed of the induction motor, that is the speed for the DC generator as well, the same speed. So therefore, from the very first line of the problem, everybody find out what is the induction motor speed, which will be the DC generator shaft speed, and then convert that speed into RPM. Everybody, do you get me?
Yeah, I think so.
Yeah. Sorry,
Yeah,
did you get?
Hit exactly 3. I got like 3.1 something.
Oh yeah. Then you have to tell this is the 3. Yeah, because the number of conductors, so it cannot be the fraction. So that's why it is like 3.
Would you just round like in normal conditions?
Yeah. is everybody doing? So is there anybody who got the result the same as well?
Yes.
Okay, so you got gold, right? 3.
Yes.
Yeah, I got 3 as well.
Okay, great. Great. Moses?
Yes, yes. Now I have. Sorry, I'm so sorry. This took a while.
No, that's fine. So everybody please take care. I'm just making sure that you're all doing and then getting. Hello, Alazmi, are you doing?
Hello.
Hello, so are you doing and are you getting result?
Yeah, I'm still working.
Oh, okay. Okay. So therefore, everybody to get the speed, as you can see the information at the very first line, 3 horsepower, 50 Newton meter. So those are the two specifications for the induction motor. So therefore, 3 horsepower is the output power. You have to convert into what? By multiplying 746, and you have to divide by the torque value 50 Newton meter. Then you will be getting omega, that is speed, in radian per second. So therefore, 3 horsepower divided by 15 Newton meter, that will give you omega. And then you convert that radian per second into RPM. That RPM value will go into your E equation for the N. And then, as I said, flux per pole, that would be 5 Webers. It is just that tricky. It is mentioned in that way. It's proportional to the excitation current. This means if you assume proportionality constant is 1, that is the same value, which is 5 ampere. So flux per pole is 5 Webers. And then rest of the thing are fine. E value is given 750. So you should be getting G value 3. Moses, finally, did you get that Z number 3?
Yes, yes, yes. I did.
Okay, oh, great. So, hold on, I think not here. Okay, so everybody see this on the topmost picture. This will be your simple schematic. Left side, I have shown induction motor, and it is the common shaft which is connected to the DC generator shaft. You have to find out G, number of conductors in the DC generator. So therefore, I have written Parameters for induction motor: 3 horsepower, 15 Newton meter, 60 hertz. All those three are for induction motor. And then first I have written down that equation, phi gn over 60 multiplied by phi by a. And right side I have written, everybody see, phi is proportional to 5 ampere. And assuming proportionality constant 1, then 5 is 5 wevers. And then on the left side, I am calculating omega 3 multiplied by 746 over 15. And I got 149.2 radian per second. And then I converted into RPM, which is the n for this equation. And then it says number of poles is twice the parallel paths. So if you say parallel path is A, then pole number is 2A. This means 2 times. So A will be cancelled, it is 2. So ultimately you will be getting Z value 3. So therefore, everybody see, those who are still calculating, look the calculation and then match with your notes that how you are doing and complete it. Is everybody fine with this one?
Yes, so far. Yeah.
Does anybody have any questions? So therefore, again, like I'm going to upload this slide together with this one. I mean, once I uploaded these notes, but I think I did not add this, my handwritten calculation together with the slide. So right after the class, I am going to update that class lecture. I think it will be class lecture 16 on the eCoursera. I am going to upload. And then again, of course, I will be uploading the video that you know. So from now on, everybody, today, like you have some quiz. Everybody, please answer. There are 6 questions. Please you answer these 6 questions. You are free to open the class notes from the eCoursera. You open your note and see the class lecture or anything. And then you please write down the answers for all those 6 questions. The answer would not be long. I mean, it should be just exact. It should be to the point. You might draw diagram, whatever, for your better own understanding and better explanation purpose. You do that. So everybody please take 1 or 2 pieces of paper. You write down your name. And once you are done, then you have to upload. I have created a Dropbox called Class Quiz 1. There you will be uploading. Therefore, everybody start. Now, you keep trying. If you are done until 11:05, then you are fine. You upload the scanned version on Dropbox. So if you need more time, then, but everybody now start trying.
What time does the Dropbox close?
I think I set up the midnight, 11:30 p.m. So tonight, everybody, that I'm going to send out an email after the class. So the deadline is tonight, 11:30 p.m.
Does it have to be paper or can we type it?
Well, you can type, no problem. So everybody, like, if you think that you will be typing in a Word file and then you will be uploading PDF file, that is fine. Or if you write by hand using pen and paper, that is also fine, no problem. So therefore, everybody, if you write down the answer in Word file, then properly write down your name, of course, because you have to upload on the Dropbox. So name of the Dropbox on the eCoursera, Class Quiz 1. You can see Class Quiz 1. So therefore, everybody see those questions and you open your note, eCoursera sources or any source, anything. So the first question is, what is the basic difference between a synchronous generator, DC generator? This means how do you distinguish a synchronous generator from the DC generator? So you may write few points. Then question 2, what is the back voltage of DC motor? What is that? And how does the back voltage of DC motor differ from that of a synchronous motor? So everybody remembered when we were studying few classes back synchronous motor has also the back voltage. So, but what is the difference between the back voltage for DC motor and for synchronous motor? So what is the difference that you are noticing? And then question 3, why is a starter needed in a DC motor? And question 4, why should the field circuit of a DC motor never be left open? And question 5, what is field flashing? What is the meaning of field flashing? And what is residual magnetism? And question 6, what is armature reaction in DC machines? And how can the effect of armature reaction be reduced or minimized or cancelled? So everybody, you're free to open the eCourseware material, previous class lectures, today's class discussion, and so anything, any source, feel free. But you have to answer, and answer would not be too long, but it should be appropriate and to the point, exact. So therefore, if anybody is done with all the 6 answers, like by 11:05, then you're fine. You are good to go. You can upload on that Dropbox, then you're fine. And then if you are not done, then take time, because you might have other classes after this on. So you do, and then that's why I have allowed long time until 11:30 p.m. tonight. You have to upload. But now everybody, please try your best to see and to find the answers. So you will be facing similar questions in the next week in the upcoming midterm exam.
And you said the midterm is the 22nd, correct?
22nd, right? Yeah, I think it is Thursday. Initially, I told the wrong. I think Tuesday, but not Tuesday. I think it is Thursday.
Thank you. I was just making sure.
Yeah, no, I will alert you all. I think in next class I will show on slide about that. I will remind you all. So definitely you will be asked this type of similar questions. So and then if you upload today that, and I will return you hopefully in next class. I will be making some grading, and then I will be returning those graded things. Returning means I will write the feedback and I will discuss. And also I think I have not yet graded your homework 3 that I will be doing hopefully today or tomorrow. And of course, you all will be submitting the homework 4 by Friday, and that I will let you know the grade by Tuesday. So then you all are ready for the exam on Thursday next week. So including today's class, like we are almost about 70% done for the syllabus. So therefore remaining 30% for the, in a month we will be done. So we are almost done 70% of the syllabus. So from next class, I will start the new topics, single phase motors. All like there are lots of motors, single phase motor, the motor used in ceiling fan and lots of things. All those small motors that I will be discussing from next class. And then finally the transients in machines, electric machines. So therefore, I would say about 30% of the syllabus is remaining. We are almost done about 70%. Are you all answering the questions?
Yes, right now, yes.
Okay, great. Yeah. As I said, you all are free to open any source, anything. So mainly, if you see the class notes, class lectures uploaded on eCourseWare, the previous classes, then you will get the answers. You can see the answers will come from those slides. And as I said, I mean, of course, you can write the answer only in sentences in text. But if you think that you will be drawing a schematic, then that you are, of course, most welcome. You can draw the brief schematic for the better explanation that you can do. So no problem. Or if you think, no, I will be just writing the text sentences, that is also fine. So are you all answering?
Yes, almost finished.
Okay, yeah.
And then just scan and upload to the Dropbox, correct?
Yeah, right, yeah. So if you are done, then so why not uploading on the Dropbox? The Dropbox name class quiz 1. I mean, right after the class, I am going to send out an email to everybody by mentioning the name of that class quiz Dropbox. Therefore, everybody, please don't forget to write down your name on that paper, or if you're typing in Node file, whatever, so please write down your name.
Dr. Ali, the only one I'm having trouble with is the second part of number 2.
Okay. So how does the back voltage? So this means for the DC motor, you know what is the back voltage, right? Yeah, that EB. So what is the feature of the back voltage that you are noticing in DC motor versus what are the features of back voltage for synchronous motor? You need to write down those things.
Okay.
Yeah, that will be the answer. So therefore, what you are noticing now for the DC motor, that back voltage, what is its feature? Like you can say, how does it look like in compared to the input voltage, terminal voltage? Similarly, go to the synchronous motor. Synchronous motor has also back BMF. What is the relationship of that back voltage to the input voltage for the synchronous motor? There is difference there. So I just give you the hints. I mean, you can relate the input voltage and the back voltage. What is that for DC motor versus what is that for the synchronous motor?
Thank you.
Yeah, okay, welcome. Okay, everybody, then I think now it's the time to finish the class, and then some of you have definitely the next class. So you keep going. If anybody is done with the answering, then definitely you go ahead and upload on the Dropbox class quiz on. And then those who are still answering, then you keep going, and then keep in mind that you must upload the quiz by 11:30 p.m. tonight. So I'm going to, these things already in the class page, but again, I'm going to upload the uploaded slides right after this class. In few minutes, I will be uploading on eCourseWare. And then these questions will be located in the last slides of today's class. When it is class lecture 16, it will be the last slide. So again, you will look, and then once you are done, you upload. Okay, so is everybody fine? So I'm going to stop sharing this slide now.